So for multiplying polynomials, there's two parts to it. This first part, it's asking you to find the sum in each row. So that means that we'll solve, I'm going to do number 5 with you. We'll solve both of these. We'll simplify both the expressions. I'm going to go a little zoom in on this. So we use the box method typically when multiplying out 2x minus 10 and x minus plus 3. So 2x times x is 2x squared. X times negative 10 is negative 10x. 2x times 3 is 6x. And negative 10 times 3 is negative 30. And so I get an expression of 2x squared minus 4x minus 30. Do the same thing with this, another little box. So this is the work that I'm talking about. So we've got 3x plus 1, x minus 4. So you can squeeze it in here. You can also shrink down your little pen, make it a little finer. So this will be 3x squared, 1x, negative 12x, and negative 4. And so this simplifies down to become, what would that be? 3x squared minus 11x minus 4. Now this is asking for the sum of these two. So I need to combine some like terms. So it looks like I've got 2x squared and 3x squared, which will make 5x squared. I've got negative 4x and negative 11x, which is negative 15x. And then I've got negative 30 and negative 4 to make negative 34. And hopefully, when we go down to the bottom, we see an answer that looks just like that. Negative 34, there it is. So that means that I'm going to color all of the number 5s in yellow. And this is 100% optional. It's kind of fun, though. But anytime you see a 5, you'll color it in yellow. So I see a little 5 there, so I'd go, color that in yellow. Obviously, the coloring part is not at all what I'm really looking for. If you just color, that's fantastic, but it's the work that I'm looking for. So this is considered the work that I want to see. And then for the second part, it's asking for the difference in each row. So this is slightly different. So let's look at, I'm going to do the last one on the bottom here because we haven't really done trinomials. I see 2 terms by 3 terms, so binomial times trinomial. So when we do the box method, we're going to use a longer box to multiply it all out. And so we'll place the x squared, negative 10x, and 2 with 3x and 5 to get 3x to the power of 3, because that's to the power of 2 times 1. And then 5x squared, negative 30x squared, negative 50x, 6x, and 10. So when I add this whole thing together, I'm going to get, let's see, 3x to the power of 3. These two will combine to make negative 25x squared. These two will combine to make negative 44x, and then the 10 at the end. So same idea with this next one, doing a little longer box. To divide it into 3, we've got x squared minus 3x minus 7, 2x minus 1, so that's 2x cubed, negative 1x squared, negative 6x squared, 3x, negative 14x, and 7. So again, we can combine these. Now this is a difference. So I'm going to do a little minus sign there. And then I've got my 2x to the power of 3. These two combine to make negative 7x squared, negative 11x, and then a 7. So when we subtract, I personally like to distribute that negative 1 to all the terms because that's commonly where the mistakes can happen. So I'm going to do that and just quickly get my 3x cubed minus 25x squared minus 44x plus 10 minus 2x cubed plus 7x squared. So it's just changing all of those signs, plus 11x minus 7. So now I can combine them up. You don't have to do this, but again, it prevents those mistakes that can come up. So that's going to be x to the power of 3, 3 minus 2. This one will become, so negative 25 plus 7 is negative 18x squared. 44 and 11 is negative 33x, and squiggle, squiggle is positive 3. So negative 18, negative 33. Oh, look at that, light blue. So anything I see for number 12 is going to be colored in light blue. Now, just the last little hint for these two, because it's so common. Don't be a silly Sally. Silly Sally. would say, oh yeah, I can distribute the exponent and do 3x squared minus 1 squared. These two are not equal to each other. Do not do that. I will be very unhappy. Instead, what we know is that an exponent of 2 means that you can multiply this out by itself, and that creates your two binomials that you can then either use distribution or the box method. And we like that. That's the correct way to go.